Hello, my name is Curtis Wilkerson, and I am a Quality Assurance Engineer for the Mars Science Laboratory rover. And this is the Jet Propulsion Laboratory Spacecraft Assembly Facility. This is literally where it all comes together. Come on, let's go inside. When we're building a spacecraft, all of its parts are brought here to the clean room for final assembly. So why do we use a clean room? Because dust particles and other microscopic contaminants can harm our sensitive equipment and optics. So we have to remove those particles from the air. Also, tiny airborne life forms called microbes coexist with us. We have to remove those as well because we don't want to visit another planet and think we've discovered life just to find out we brought it with us from Earth. This clean room is configured as a Class 10,000 clean room. That means that within 1 cubic foot of air, there can be no more than 10,000 particles the size of half of a micron. Half of a micron is 200 times smaller than the width of a human hair. Now, if 10,000 sounds like a lot, by comparison, the room that we're standing in has nearly 500,000 to 1 million particles within 1 cubic foot that are larger than half a micron. So where do all these particles come from? Well, most of them come from us, the people. Things like skin flakes, our hair, cosmetics, even the lint on our clothes. When we're standing still, motionless, we shed more than 100,000 particles per minute. We're also worried about triboelectric charging. And that's just a fancy way of saying static electricity. You know how it feels when you're walking along a carpet and you touch a doorknob and you get that little shock? Well, that is more than 2,000 volts of electricity. That kind of shock can do a lot of damage to our electronics and sensitive equipment. So to prevent static electricity and contamination, we wear a special clean room garment you may have noticed. We call it a bunny suit. Come on, let's suit up. Inside the clean room, the air is kept clean by a special ventilation system. On this side of the room, air is blown in while existing air is sucked out on the north side of the room. It's then recirculated through HEPA filters and carbon filters before being blown back into the clean room. We also move our heavy equipment with large cranes. The crane above us has a capacity of 15 tons. Inside the clean room, we're building the Mars Science Laboratory, the next rover going to Mars. We have 4 large components in here today. Behind me is the back shell. During our 10-month cruise, this will be the home of our rover. It's covered in a white thermal protection system right now to protect it during entry into the planet. Here we have the descent stage. Some call it the sky crane. After we detach from the parachute, this has the responsibility of lowering the rover with the help of 8 retro rockets seen in red to a soft landing on the surface of Mars. At nearly 16 feet in diameter, our cruise stage gets us from Earth to Mars. With solar panels on the top, we have power, antennas pointing towards Earth, we have communication, and with the little rockets in the corner in red, we can make small trajectory maneuvers during our cruise. And here's the reason we're going to Mars, the Mars Science Laboratory rover, the largest rover this planet has ever sent to Mars. It's mid-October, and right now we're doing a lot of electrical testing, but the closer we get to our launch date, we'll start adding our wheels and our mast with the cameras, and then the robotic arm. They'll really start to take form. Once we're finished with all our assembly and tests, we'll pack it up and ship it to Cape Canaveral, Florida at Kennedy Space Center. We'll go through even more tests before we stack it on a rocket and launch it to Mars. I gotta get back to work, but I hope you enjoyed your tour. From NASA and JPL, I'm Curtis Wilkerson.